So today we are going to learn about an important phenomenon in chemistry, that is Tyndall effect. Before learning what is Tyndall effect, we are supposed to be clear with certain terms like what is meant by solution, what is suspension and what is colloid. These terms we are going to learn experimentally today. I have taken a glass full of water. Now I am putting some salt into it and I am stirring it. What happened to the salt particles? They got dissolved. They got disappeared. They got disappeared. Can you say any salt particles still?
No.
No. They got completely dissolved in this water. Where they might have gone? Where have the salt particles gone? They got dissolved completely in this water. Now can you spotify any salt particle here? No, we cannot spot any salt particle. Such mixture we call it as a homogeneous mixture. What do we call? A homogeneous mixture. Homo means same. So same, the solute, the salt which we have dissolved in this, in a lesser quantity we have dissolved the salt. So that part which are dissolving, which we are dissolving this solvent, that is water, we call it as solute, and the water which we have taken in the larger quantity, that we call as solvent. Solute is the quantity which we take in smaller amount, that is the salt, and the quantity which we have taken in a larger amount, that is water, is called solvent. If the solute gets completely dissolved in the solvent, we call that such mixture as homogeneous mixture, also called as solution. So this is a solution. See, it is looking like a clear water, right? We cannot see any salt particles in this. We are putting this aside. Now take another glass full of water. Now what I am going to do is, I am taken some sand and I am mixing it. See? Does the sand mix in this water?
No.
Does the sand just like salt? Does the sand mix in this water?
No.
No, it does not mix in the water. Okay, is this water clear just like salt water?
No.
Is this water clear?
No.
No. So here what is the solute? Solute is the sand which we have mixed and the solvent is water. So in this, the solute does not get dissolved in the solvent. And if you leave this solution, if you leave this mixture for some time, what happens is all the sand which we have mixed, it will settle at the bottom. So such mixtures are called heterogeneous mixtures. Hetero means different. Heterogeneous mixtures. That means in heterogeneous mixtures, the solute particles, they are not going to dissolve in the solvent. Okay? Their solute particles, they are going to be suspended in the solvent. So such mixtures are called heterogeneous mixtures, and since the solute is suspended in the solvent, we call them as suspensions. So heterogeneous mixtures are also called as suspensions. Clear? Now I have taken another glass and I put some milk into this. Okay? And I dissolved it. Now can you see the milk particles here?
No.
We cannot see the milk particles, but still the solution is not clear as salt water. Okay? So such mixtures we call it as colloids. So in this, the solute is milk and the solvent is water. The solute particles, the size of the solute particles is intermediate between the solution and the suspension. So if you see these three mixtures, one is homogeneous, other is heterogeneous, other is colloid. So this colloid and suspension, this is also called suspension, this is solution. Okay, so these two comes under heterogeneous mixtures. Okay, so the main difference in these three glass beakers comes with the size of the solute particles. If the solute particles gets completely dissolved in the solvent, we call it as a homogeneous mixture, also called solution. If the solute particles does not get dissolved completely in the solvent, we call such mixtures as heterogeneous mixtures. And if the solute particles are large enough and we can see them with the naked eye, we call it as and they remain suspended in the solute, we call it as a suspension. And the solute particles, we cannot see them with the naked eye, but still the size of the solute particles is intermediate between the solution and the suspension. We call such a mixture as a colloid. Okay, are you clear with what is meant by solution, suspension and colloid? Now what I am going to do is, I am focusing some light into this. Now observe this clearly. So when I focus light into this homogeneous mixture, what you are going to see is this light, it passed here and you cannot see light inside the glass. It is again coming here. Now if I focus this light here, you see that we can see the light into this glass jar. Inside the light particles, inside this homogeneous mixture, they are large enough, the solute particles are large enough and they are scattering the light. And we can see light inside the glass jar. Can you see the light inside the glass jar? Why this is so? Because the solute particles are large enough and they are scattering the light. Similarly, the colloid, if you take, it is also a heterogeneous mixture. It looks like homogeneous mixture. It is not a homogeneous mixture. It looks like that, but it is a heterogeneous mixture. But the solute particle size will be between that of solution, that is homogeneous mixture, and the suspension. But it is a heterogeneous mixture. In this also we can see light inside the glass jar. See? Can you see the light inside the glass jar? Here in this, we cannot see the light inside this glass. It is plain water. I mean salt water. This is a homogeneous mixture. Okay. So here the scattering of light rays by this suspended solute particles, we call it as Tyndall effect. What is that? Tyndall effect. The scattering of the light by the solute particles is called Tyndall effect, and it is named after a scientist called Tyndall who discovered this effect. If you see, if you take a dark room and we focus a small beam of light rays, you see that some dust particles are rolling around. In a dark room, if you just focus a sharp light, you see that when the light rays are passing, we see some kind of dust particles rolling around. Similarly, if you go in the night time on a vehicle, through the vehicle lights, we see that some dust particles are rolling around. Understand? So these are all examples of Tyndall effect. So the scattering of light by the solute particles is called Tyndall effect. So this is this interesting?
Yes.
Yes. Thank you.